Hello everyone! Let's explore Kotlin extension functions by comparing them to Java static methods. I'm going to start with a simple Java example just to give you some context, and then we'll move on to the Kotlin comparison. So let's assume that we want to extend the BigDecimal class so that we can get a fractional part from a BigDecimal and an integer part from it. For that purpose, I'll create a new Java class. I'll call it my BigDecimal util. And in Java, we can achieve this by using static methods. So we'll have a method to get the integer part. So for now, I'm just going to return zeros. And we're going to have another static method to get the fractional part. And we can write two tests for these to make sure that they fail in the beginning. So I'm going to call this my BigDecimal util test. And our first test will test the integer part. So we want the BigDecimal of 12 to be equal to the integer part of the input value here, which is 12.53. So we just want to drop the 53. And in this case, we're going to compare it to my BigDecimal util get integer part input. And we want the comparison to yield 0 to make sure that both of these are equal. So when we run the test, this one should fail because we're currently returning simply 0. And we're going to write a second test to implement the fractional part. In this case, we want 0.53 to be the answer. And this test should fail as well. As you can see, both tests fail. So let's begin by implementing the integer part. So for the implementation, we're just going to set the scale of the original input to 0. And that should just drop the fractional part, and we should be left with the integer part. If we rerun both tests, now we can see that one of the tests pass and only the fractional part fails. And we can now implement the fractional part method. In this case, we want to subtract the integer part of the original input, which will just yield the fractional remainder. Something's wrong. Oh, the test is wrong. We should be testing the fractional part and not the integer part. And in this case, both tests passed. This is typically how you would extend the functionality of library classes that you have no control over in Java. Since BigDecimal is not a final class, we can extend its functionality also by subclassing it. I'm going to create a new class and extend the BigDecimal standard library class. We need to supply at least one constructor, and I'm going to pick the string one. Now we're just going to implement the same functionality that we did in our util static methods. I'm just going to copy paste the logic here. And do the same for the fractional logic as well. Now we can test these to make sure that they work. I'm just going to duplicate the previous tests and make sure that we use the new class. Here I'm going to replace the static utility method with the new class's implementation. And we can do the same for the fractional part test. Now we expect the test to pass. Extending functionality by subclassing library classes is probably not the best idea though. Right now, BigDecimal is not final, but there's no guarantee that that will be the case in the future. And if it ever becomes not final, all of this functionality will have to be reworked, while the static extensions will remain valid. Secondly, whenever we want to use the subclassed extension methods, we have to pass our own BigDecimal class, as we're doing in this case. In a large project that uses a standard BigDecimal class in multiple places, this might require a significant refactoring effort that we probably want to avoid. So now let's take a look at how Kotlin's extension functions avoid these complexities. So I have a new Kotlin project here, and I'm going to create a new Kotlin file. Not a class, just a file. We can extend classes in Kotlin in two ways, by extension functions or by extension properties. I'll show you both in this example. So in this case, we want to extend the BigDecimal so that we can get the integer part. We can achieve this via an extension function. We specify a new function and the type that we want to extend, in this case BigDecimal. We name the extension function, in this case integer part. We specify the return value. We want to return a BigDecimal. And for now, I'm just going to return a 0. And since we're dealing with a one-liner in this case, we can use a shorthand function in Kotlin. We can get rid of the curly braces and get rid of the return keyword and just put an equal sign here. And this will be treated as the return value for the function. We can also achieve the same thing with an extension property, which reads a bit better in practice. You'll see when we move on to the test why. We can do this with a value declaration. Again, we specify the type that we want to extend and the name of the extension property, in this case fractional part. We also specify the return type, but as you can see, the difference here is that we don't include the parentheses. That's because this will be treated as a property, and since it's a property, we need to specify a getter for the property. I'm just going to return 0 in this case as well. I'm going to create a test class that we can work with. We're going to start with the integer test first. And here we use an instance of the class that we just extended and call the extension function's method name. In this case, it's input and integer part, and we want the comparison to yield 0. In this case, the test will fail because we haven't actually implemented anything in our util file. Notice that in terms of ergonomics, this looks exactly the same as the Java subclassing approach, but in this case, we're working with the standard BigDecimal class and not with our custom implementation. And we can also implement a test for the fractional part. But if you remember, the fractional part we implemented as an extension property and not extension function. So we're going to invoke it in a different way. Instead of calling it like a method, we can call it as a property. So just fractional part, like this. Under the hood, this actually acts as a function call as well, but I think it reads better. This test should fail as well. Okay, so we can move on to the implementation part. We're just gonna do the same implementation that we did in the Java case. So we're going to set the scale to 0. In this case, this keyword acts as the input parameter to the extension function. So if we compare it to the Java implementation that we did, the this keyword corresponds to this input argument here. And we can also implement the fractional part. In this case, it's this minus this integer part. We can use a minus because in Kotlin there's the concept of operator overloading. So minus is overloaded to use the subtract BigDecimal method under the hood. So in this case, both tests should pass. Under the hood, these extension methods and properties are actually implemented as static methods. And I can show you that this is the case. So here, we can take a look at the bytecode. Even though this my BigDecimal util file is not a class in Kotlin, it's just a regular file. As you can see, there's no class keyword here. Under the hood, it's implemented as a class for the JVM to use. As you can see, it's a final class with the same file name. And here we can see that there are two methods which are static. The first one is the integer part method, which corresponds to this here. It takes in a BigDecimal, which corresponds to this in our case. And the second implementation of the fractional part, even though it's just a property for the Kotlin compiler, it's actually implemented as a static method as well. You can see it here. It also takes a single argument, which is a BigDecimal. And obviously this method is a bit more involved than the method above because it has more functionality in it. But if we take a look at what it does, at some point it should invoke the integer part method. And here it is. And the IDE is complaining because I forgot to add the return type here. Thanks for watching, and if you're interested, please check out part 2 where we're going to take a look at how we can mock extension functions in tests.